Hello, my name is Joshua Mugabi. I welcome you to the Dichotomous Key, or what we also call the identification key. The dichotomous key, this is a method of grouping specimens into smaller two groups according to similarities in their observable feature. For example, the simple way, if you look here, someone may say that these ones have been grouped into two groups using observable feature, like here we can use color white and here brown. But as we shall see later, color cannot be used, as we shall talk about it. But in simple lay term, when you look at these ones, you can see that here this species is white, this species is brown. They have been grouped into two, but that is just a simple way for us to understand, but that one color cannot be used. So the specimen are grouped into two smaller groups with similar or observable features. Now the grouping must continue until one specimen remains in each group. Now, if you are grouping the organisms, you group them until one specimen remains in its own group alone. For example, if we look here we look at 5 specimens. We have the orangutan, gorilla, chimpanzee, bonobos, and humans. In 15 million years ago, it was one ancestor. They had a common ancestor. Then when it came to 13 million years ago, the orangutan separated, was identified. It went its way, and then the other ones also went the other side. Then 8 million years ago, again the gorillas now separated, and the other 3 groups moved in the other side. 6 million years ago, then the humans separated, and we remained with the chimpanzee and the bonobo. Then 3 million years ago, the chimpanzee and bonobos separated. So a dichotomous key is like that. We group them into 2 groups until when all the specimens remain each specimen in its own group. For example, we can use these organisms here. We have the fish, we have the amphibians, we have the reptiles, we have the birds, and the mammals. They can be put together and we can separate them using a dichotomous key, using their observable features. Now, the number of couplets is always less than the number of specimens by 1. Now, the number of couplets here, we have couplets, we have 4 of them. Couplets, these are the groupings. The way we are going to separate them, the steps that we are going to take. So the number of the couplets is always less than the number of the specimen. Now, when you look at the number of specimens, we have the fish, we have the amphibian, we have reptiles, we have birds, and we have mammals. So you will see that we have 5 specimens. And the 5 specimens, therefore the steps which are going to be used to separate them are what we call the couplets. And these couplets should be less than 1 by 1, the number of specimens. So if we have 5 specimens, that means the steps, the couplets we are going to use, they are going to be 4. So you have 1, 2, 3, 4. Those are the ones that we are going to use. Now, start dichotomous key with clear, commonly understood, observable future. For example, here we are using understandable, understood, observable future. For example, we have here poikilothermic in the first couple and homeothermic. These are cold-blooded, these are warm-blooded. We separate them using that common future. But it should be observable. It should be observable. As we shall see later on, this one poikilothermic and homeothermic, they are not observable. Therefore, these ones may not be used here. But we are saying that you use those ones which are easily understood. Poikilothermic, they are cold-blooded. Homeothermic, they are warm-blooded. Now, key does not have a specific answer. They don't have a specific answer that when I make the key, I will start with this one, I will start with this one. No, just use the correct future and proceed. Someone may start with this, other one may start with this one, now this one may be the last one. So it does not have a specific answer. For you, just use the correct future and you proceed. Characteristics or characters used in the dichotomous key. 1. They must be permanent. The characters that you are going to use for your dichotomous key must be permanent, meaning that they don't change. For example, if you look at these lobes, you look, it is a lobed. You look, it has a stalk. Those ones are permanent. They cannot change. Should not change with the environment or time. They should not change with the environment or they should not change with time. Those are the characters that you are going to use. For example, color of leaves are not used in the dichotomous key. You cannot use color because if you look at this one, this is the same specimen. And you can see that they have got different colors. So which means that the color changes with the environment and the time. Therefore, we cannot use color because it is not permanent. Characters should be observable or tangible at the time of the experiment. They are observable. Characters are observable and tangible at the time of the experiment. Now, for example, if you look here, we have poikilothermic and homeothermic. This is not observable. This character is not observable. Poikilothermic, homeothermic, you cannot observe them. Therefore, we cannot use this character because it is not observable. Then now when we come, they have fin on the limbs, has 4 limbs. Are these observable? Yes, those characters are observable. Then we have has no scale on the body and has scale. Are they observable or not observable? They are observable. Then we have has feathers, has fur. Are they observable or non-observable? They are observable. So we use observable or tangible characters at that particular time of the experiment. Use descriptive features, not group names. We are supposed to use something describing, not a group name. For example, if you look here, we can say it has leaflet. Okay, that is a descriptive feature. But we don't say it is a compound leaf, a group name. No, we use descriptive features. They have leaflets but not compound leaves. Here we can say it has 3 leaflets, 1, 2, 3. But we don't say it is a trifoliate. For insects here we can say has 3 pairs of legs, but we can't say they are insects. Okay, this is a group name. This is a descriptive feature. It has 3 pairs of legs, but we know that it have got 3 pairs of legs. They are insects, so we cannot say they are insects because that is a group name, but we can say they have 3 pairs of legs. Name and groups are not observable. Names and groups are not observable. State a structure but not its function. We have to use a structure but not its function. For example, if you look at these insects here, it has proboscis. It has proboscis. It has proboscis, but we cannot say sucking mouth part. It has sucking mouth part. No, we say it has proboscis. The structure. We talk of the structure, not the function. Sucking is function. Proboscis is the structure. It has a structure. We don't say it has a sucking or sucking mouth part. Sucking is a function. We don't use functions, we use structures. Do not use one statement more than once. We don't use one statement more than once. For example, here we can say it has a broad lamina. It has a broad lamina. It has a divided lamina. Okay, divided lamina. Those are two different. Okay, broad is different from divided lamina. Okay. Wrong to say and acceptable words to say. Biting mouth parts, that is wrong. Okay. Has pair of compound eyes, that one is acceptable. Has hairs on stigma, is it acceptable or wrong? It is acceptable. Has few stamen, is it acceptable? Wrong. Has many glands, is it acceptable? Wrong. Has a pair of antennae, is it acceptable? Yes, acceptable. Has it can see, that is wrong. Lamina divided into leaflets, acceptable. Has proboscis, acceptable. Has wide abdomen, wrong. Has hairless stigma, wrong. Has tits or nipples, acceptable. It can feel, wrong. Has mandible, acceptable. Has broad abdomen, acceptable. Compound leaf, wrong. Has no eyes, has no leaflet, wrong. No eyes, no leaflet, acceptable. Now let us look at how we can give these ones. For example, we have our guinea leaf here. A lamina, we can say, has hairs, that is the lamina, not divided into leaflets. It is narrow, it is thin. When it comes to the vein, we can say they are parallel. The margin is rough and entire. Petiole, it is sheathed. Petiole is sheathed. Folded. Long petiole. it is thin. We can use those characteristics. Okay? And it has hair. When you come to the hibiscus flower, the lamina is smooth, as you can see, not divided into leaflets. It is broad. It is thin. The vein, it is network type of vein, as you can see. The margin is serrated. You can see it serrated. And the petiole is short and solid. When you come to cassia, the lamina is smooth. It is thin, divided into many leaflets, as you can see. All of this is a lamina, and it's divided into many leaflets, and it has hairs. It is broad. Leaflets are in pair. You can see the leaflets are in pairs. Then the veins, it has network venation. The margin is divided. The petiole is long and solid. Then also grooved. It is grooved where it attaches itself to the stem. The beans, the margin is smooth, thin, divided into 3 leaflets, has hair, broad, network venation. Margin is divided, has a long petiole and solid, and also grooved, and it has got hairs. Go to the cassava. The lamina is smooth, thin, deep lobes. It is broad, not divided into many leaflets. It has network venation. The margin is lobed. The petiole is long. It is solid, grooved towards the base. We go to the pawpaw. The lamina is smooth. It has many lobes. It is broad, not divided into leaflets. The vein is network venation. The margin is bilobed. The petiole is smooth, long, and hollow. Let us look at these specimens: specimen A, specimen B, specimen C, D, E, and F. You're supposed to carry out a dichotomous key. You can pause the video and you carry out a dichotomous key. Here, when we look at them, we get our first couplet, and we say we shall use the lamina divided into leaflets. So you look at them and see the lamina which is divided into leaflets. Then you send them to 2, because there are very many of them divided into leaflets. Send them to 2. Then you say lamina not divided into leaflets. These ones, we have this, we have this, we have this. Then you also have this. You send them to 3. Then you make the second couplet. You choose the first one. The 2 that we are sent here, it has short petiole, that is C. Okay, Then it has a long petiole. We have D. Okay. Then we continue. Third, we had put there those ones. Petiole is sheathed. That one is A. Petiole is not sheathed. That one we have. Let we take them to 4. Then click 4, couplet 4 has hollow petiole, that is F, purple. It has a solid petiole, we go to 5. Couplet has serrated margin, that is B, and it has lobed margin, that is E. So that is our dichotomous key. We said that the couplet should be less by 1 the number of specimen. If you look at the specimen, we have 1, 2, 3, 4, 5, 6. So the couplet, the steps are going to be 5, and all of them will be separated. So now you look at those specimens and try to make a dichotomous key out of them. Also look at those ones and make a dichotomous key. Thank you very much for participating in the dichotomous key identification key. Please do like, share, and subscribe.